So in this question, we're looking to find the y-intercepts of two different lines parallel to the line 4x plus 3y minus 7 is equal to 0. So this is just going to be the equation of our first line we're given in the question. And these two lines need to pass through the points 2, minus 1 and minus 3, 5 respectively. So basically two different lines here, and we're looking for the y-intercepts of them. And so because we're looking for two lines, we first of all need to identify what information we need to actually find these lines. And the first key piece of information is going to be the slopes. So we need the slopes of these two lines. And so that's going to be very important, but we actually have the slopes already because we know they're parallel to the line we're given in the question. So we're going to be dealing with that in a second. And then the second key piece of information we need is 2 points which are on the lines, or 2 points which the two lines pass through. So these are going to be our 2 points once again we're given in the question. So one of the lines passes through the point 2, minus 1, and the other one passes through minus 3, 5. And so now that we know all this, we can actually find these two lines using this information, as well as our formula for finding the equation of a line, which is going to be y minus y1 is equal to m times x minus x1. So now our job is going to be to find the slope of the first line we're given in the question, which is going to remain the slope for the rest of the question. And so to find that, we need to first of all identify which form it's in. And so the line we're given in the question is going to be in the form ax plus by plus c is equal to 0. And so what that means is that the slope is going to be simply the fraction minus a over b. So that's how we find the slope when it's in this form. I'm pretty sure you need to learn this off. I don't think there's any way to actually find this directly in the log tables, so you do need to remember how to find the slope given the form of the line. But in any case, we can do that now. So we can simply read our numbers from the question. So a is going to be 4, so it's going to be minus 4, that's minus a, over b, which we know is going to be 3. So the slope of all these three lines that we're dealing with in this question is going to be minus 4 over 3. And then we just pick one of our 2 points to deal with first. And so our first x1, y1 for the use of this formula is just going to be 2 minus 1. So that's going to be the point we use for our formula now. So now just beginning to plug this in, we have y minus y1, which is just going to be y minus 1. So that's going to be straight away from just reading it from x1, y1. And so that's going to be the left hand side of our formula, and then on the right hand side we have our slope m, which is going to be multiplied by x minus x1 or x minus 2, because once again we're dealing with the point 2 minus 1 here. So hopefully this is easy enough to follow. And now our last kind of step for finding the first one of these two lines which passes through the point 2 minus 1 is just going to be to tidy this up. So we have we have plus 1 on the left hand side. So we have y plus 1 is going to be equal to minus 4 over 3 times x, and we have minus 4 over 3 times minus 2, which is going to become a positive, so we have 8 over 3 as our constant there in the end. So we're basically going to stick to the form that they've given us in the question, which is to get everything on one side. So we have ax plus by plus c is equal to 0. You can also do it, I'm sure, as y is equal to mx plus c, because they don't actually specify which of the two forms you should put your line in, so it should be okay either way. But we're just going to basically sort everything out here on one side. So we have, just subtracting across by y, we have minus 4 over 3 times x minus y. Then finally we subtract across by 1 as well. That is going to be 8 over 3. Subtracting 1 is going to give you 5 over 3. And so this is going to be the first line that we have in this question. So we've just used our points and our slope to find that. What you could also do is try to get rid of a few of the minuses by multiplying across by minus 1. Actually, we should have an equal to 0 here as well. That's my mistake. So we have equals to 0 on the right hand side. But you could multiply across by minus 1 to get rid of the minuses on your x and y, but there's not really any strict need to do that, so we can leave it in this form. And so now our job is going to be to repeat the exact same process except for our second line. So our second line is going to be using a different points, again with the same slope. And so this time if we look at our question, our x1, y1 is going to be the point minus 3, 5. And so now we can use our formula once again for finding the equation of a line, which is going to be y minus y1 to start off. So we're going to have y minus 5, just taking once again the y coordinate of our points. Then we have our slope m, which is going to be minus 4 over 3 times x minus x1, which is going to be x minus 3, which is going to become x plus 3. So hopefully that's making sense. And our job once again becomes to just tidy this up. So we're going to leave the left hand side the same for now. Then we have minus 4 over 3 times x plus 3 times minus 4 over 3, which is going to become minus 4 actually. So I'll just fix the sign on that. So we have minus 4 in the end, and as we did for our first line, we're just going to tidy up this into the correct form. And so following the same process now to get everything on one side, we can simply write it as minus 4 over 3 times x minus y, so subtracting across our y, and then adding across our 5. So just be careful with that. So we have a minus 5 we're looking to get rid of, so we need to add across by 5. That's going to become minus 4 plus 5, which becomes plus 1. And so this is going to be how line 2 looks when we get it in the proper form. But I've actually just realised it is probably best if we get rid of our fractions for our line here. So you can see that we've got this minus 4 over 3 times x and we basically want that to just be a normal number. So if we can actually make it a positive number, that probably is the best thing to do here. So what I'm going to do for both of our lines here, line 1 and line 2, is just multiply across both by -3, so that's going to tidy up these lines. So again, just multiplying across the equations by -3 now. And so our two lines, when we tidy them up, are going to be 4x plus 3y minus 5 is equal to 0 for line 1, and then for line 2, 4x plus 3y minus 3 is equal to 0. And it is normal that they look so similar because they're parallel, and so that's going to be it for this question.